In my project, I have used an Arduino Uno R3, then an I2C LCD display. I've used a LDR sensor. This sensor will sense the intensity of light and send the value to Arduino, and the LCD will read the value. You can see the light is showing a value around 570. Uh, It depends on the light intensity. If I put a shadow here, the value will decrease. You can see the value has already decreased to 250 something, which is as expected. The temperature is currently showing 28.5 degrees, which is totally okay in my room. The values here you are seeing is, this is the interesting part. This is the actually threshold values. So I have set the threshold value for light to 400, which means if the value of light here goes below the 400, then this LED, green LED, will turn on. So let me show you. If I see, it became dark and the value decreased less than 400. See, you can see the value of light has decreased to 251, which is obviously less than 400, and this LED has turned on. And similarly, I have set the temperature threshold voltage to 35 degree. So whenever the temperature goes up to 35, goes more than 35 degrees, this red LED will turn on. So instead of raising the temperature here, for safety, I will change the threshold voltage with this keypad. First of all, you have to press the button A. The LCD is saying to set threshold voltage of light or temperature. So I will set the threshold of temperature. So I will press 2 here. So I have to put the value of temperature threshold. Since it's 28 degree in my room, so I will put the temperature threshold to 20 degrees Celsius to 0. You see, I put the value of 20. Now I have to press hash. Hash means save and star means exit. So I will save this value here. Set complete. You can see that the temperature threshold has been changed to 20 degrees Celsius. So, and currently my room temperature is 28 degree, which is above the threshold voltage. So the red LED will turn on. As I said, you can see it has turned on, the red LED. Also, if I put a shadow in the LDR sensor, the value of light will decrease. Both the LED will turn on. You can see the values here. I hope you know how it works. Also, these values will go directly to a IoT server, which I will show you at the last. So first of all, how I have set up this, I'll show you. We have to connect this LDR sensor. One leg will go to VCC. Here this bus, I made a bus of VCC and ground here. So this leg will go to VCC and the second leg will be connected to A0 of Arduino Uno. Also this leg will be connected with a 10 kilo ohm resistor. Since I don't have a 10 kilo ohm resistor, I used 10 of 1 kilo ohm resistors in series. So you just have to use one piece of 10 kilo ohm resistor. It will work perfectly fine. Um, this wire is unnecessary. Actually, I forgot to remove it. Okay. Now the end of the resistor is connected with ground. Okay. So LDR setup is done. Now I have to set up this LM35 sensor. The pin 1 here, it goes to VCC. The second pin will go to A1 pin of Arduino Uno here, and the third pin of LM35 sensor will go to the ground here. It goes to the ground. Okay, and you have to must put a capacitor of 0.1 microfarad, otherwise the values will fluctuate too much. So you must have to put a capacitor here between pin 2 and pin 3 of LM35. Okay, this one is also done. So next you have to set up these two LEDs. So green LEDs positive leg will be connected to a 1 kilo ohm resistor, and here I have connected the VCC, and here I have connected the ground. Similarly, you have to connect the red LED with a resistor, which here is the VCC and here is the ground. Okay, LEDs are also done. Now you have to connect the I2C. I hope you know how to connect the I2C LCD display. This is ground VCC. The SDA will be connected to A4 of the Arduino Uno, and SCL pin will be connected to A5 of the Arduino Uno. And think this is I have one thing left. This is the 4x4 keypad which has 8 wires. So you have to serially connect all the wires. I have connected from digital pin 3, 4, 5, 6, 7, 10, 11. From pin pin 2 to pin 11. You just have to connect it serially, but I have write the code according to this. The first one, you can see the first one here, the topmost left here, the brown wire goes to the pin of digital pin 2. Then the next one goes to 3, 4, 5, 6, 9, 7, 8 is already occupied. Oh, I forgot to tell you that the green LED, here, this wire, is connected to digital pin 7. Sorry, I mistakenly said it's connected to VCC. It's actually connected to digital pin 7. And this red LED's wire is connected to digital pin 8. Okay. So I think this is all. The all connection is done. Now you have to upload the Arduino Uno code up here, which is this. You have to upload the Arduino code. This code became too much long just because of the keypad conditions I have to set, which is totally worth it. After uploading the Arduino code, the values will be shown up here, as you can see. Then you have to write this Python code in a folder text document, and then save it .py. You can find this code in my GitHub also. So after running this Python code, this will show the values here. The real-time values. See, it matches with the values of LCD. If I decrease the light intensity to 300, you can see it has decreased here too. So now I have to upload this data to ThinkSpeak website, which works as IoT. Here you have to create an account, and then you have to create a new channel. You have to set a graph name LDR and a graph with name temperature. So when you run the Python code, the values will be updated here in real time to the internet. And that's all.